Hello everyone. In this particular video, we are going to learn pandas in and out. We'll start from the very basics of what is Panda and how to just run basic programs and basic code of pandas. Then we'll jump to intermediate and the advanced level of pandas. Now, Pandas is actually a Python package which is mostly used when you are working with a lot of data. If you want to predict some patterns from a particular data or you want to analyze a particular data, then Pandas is the go-to package for you. Now, Pandas is mostly used by data scientists because it is very helpful for cleaning the data, for analyzing the data, and we'll slowly see how helpful it is going to be for us. So let's get started. First of all, as I am on the Jupyter notebook, so I do not need to install pandas into my system. But if you are working on a code editor like Visual Studio Code or PyCharm, then you just need to write pip install pandas and it will get installed into your system. It's just a one line thing. So what I'm going to do is I'll firstly import pandas into our program. So I'll write import pandas as PD. It's normally written as PD. You can use any alphabet or word which you preferably like. Now, the first thing that we are going to learn is series in pandas. What is series? So let's say that I have a list in which there is some data. This is a particular data. Now, let's say if I want to number them and view them as a list or as a table where each record has a particular number, a particular index to it, then what I can do is I can print pd dot series, and in that series I'll pass our list. So if I'll run this, I get this as an output that on the 0th position we have the number 3, on the first we have the number 4, on 2, 5, and so on. So viewing data like this gets very easy and it's quite readable, it's quite human readable. And if we want to just get a particular element, then too we can do it. Like what I can do is if I want to view what does the index number second have in it, then what I'll do over here is store, I'll say data equals pd dot series, and I'll store this into this data variable and then pass data second element. And now if I'll run this, then I'll see that I get the number 5, which is our integer. As you can see, we can confirm it at that on the second position we have 5. Now moving on, we can even add custom labels to our series list. And firstly, what are labels? So let's say I'll print data over here. So the index that we were seeing, the 0, 1, 2, 3, 4, 5, is called labels. Now I can also add custom labels of my own if I want. And how can we do that? In this line pd.series, I'll just add a comma and write index equals. You need to give a list because we have 5 elements into a list, 6 elements actually. So I'll say A, comma B, comma C, comma D, E, and F. And now if I run my data, I see that the indexes, the labels have been changed. They are custom ones. And similarly, you can also call this particular data with these labels. For instance, I can write print data whose label is, let's say, D, and this should just work fine. We get 7 as D has the 7th number in it. Now if we are also working with a dictionary, let's say my dict, and we'll store let's say names and marks. So I'll say A has 35 marks, B has 40 marks, and C has 87 marks, let's say. And now if I'll try to series this data, then what I get is, I'll just pass my dict over here, and now I get this data series. Now there is one thing to note, that when we are passing dictionary into the series function, then labels by default are the key values. Whatever is the key is going to be the label for the series, and the value is obviously going to be the value. And then moving forward, now let's say that if I have a very big table, now what does that big table look like? I'll just copy it over here that I have pre-written it. Now this is the data that we have. It is actually a dictionary, and within that dictionary, the key calories has a list passed as a value to it, and the duration key also has a list passed to it. Now if I want to view, if let's say I'll just pass, or I'll just print again a series of it, then what happens is, over here I get calories and a list, then duration and a list. So for a person who is not a programmer, or your client who has given you this data and he wants you to clean it up in a proper way, then this doesn't actually look good to view. As you can see, calories and there's a list, and it's not quite visible. So if you want to view such a thing as a table, or into a more cleaner form, then what we'll do is we'll use the word or the keyword data frame. It is a function of pandas, and what it gives us as an input is that we have a series over here, we have an index, and it properly forms a table where we have calories 420 and the duration is 50. Then on the first index we have 380 calories and the duration is 40. Second index 390 calories and duration is 45. So that's the difference between data frames and series. If you want to watch, or if you want to display the entire data table and in a more cleaner way, then you can use data frame. And if you just want to index the data, then we can use the series function. Moving forward, also get a particular record from a data frame. That is, if I want the 0th record of this table, then it's quite easy. What I can do is I'll just write pd.dataframe, and now firstly what I'll do is I'll store this into a variable, that is sample, and then I'll pass sample dot oops I'll pass sample dot lock. This function gives us the record for the particular index that we type in. So if I'll say 1 and hit an enter, then I get this weird line, which is not what we wanted, because over here we have used circular brackets. We actually need to use the square brackets to get a particular record. So now if I'll run this, I'll get calories 380, duration 40, and name is 1, which is the index. Now something to note over here is that when we want to select a particular record from a data frame, then it is displayed as a series. As you can see over here, this is calories, duration, and name are the labels, and 380, 40, and 1 is the data. On the other hand, if I want to gather some specific records, some specific lines of records, then what I can do is I can pass it as a list. I can write 1 comma 2. Let's say I want the first and the second record. This is actually not the first, the second, but yeah, I'll run it. So there's a small error that we have made. As this is a list, we need to write it like this, within a list. And now if I run it, then I get And this time I got a data frame because the data is more than one line. So this time we got a data frame that is on the first index, calories is 380, duration is 40. On the second index, the calories is 390 and duration is 45.
Now we'll see how to load a CSV file. CSV file is basically a comma separated value file, and when a lot of data or there is data in bulk, then mostly it is stored in the CSV format because pandas can easily understand the CSV format. So I actually have a sample file called as data.csv with me, which has some sample data into it. So we are going to work with it. Now, firstly, what I'll do is I'll load this data into a variable. We'll name it again sample. And to load the CSV file, we'll write pd.read CSV and then the name of the file, that is data.csv, and I'll just print it sample. So I get the records that are present. Now, if you see, the CSV file actually has 168 records into it, actually 169 counting 0, but we are not able to view the full table that we have. So for that, what I can do is I'll just write sample dot toString. This is the function which will print the full data that we have. As you can see, every row and every record over here can be viewed when we write the toString function. So that's the main difference between toString and normally what happens is that when I do not use the toString, then the compiler just prints the first 5 records and the last 5 records onto display. Now moving forward, we'll also see how to display data that is present into a JSON file. Now JSON file is basically a Python dictionary that we all know. So what I'll do is I'll just load a JSON file, a sample JSON file that I have. Again, we'll use the same name because I'm very bad at giving names to variables. So I'll write pd.read JSON and the name of that file is data.json. And over here I'll just simply print a sample, and as I can see, this is the data. So the data looks the same, but I'll just, for people who are having a confusion between a CSV file and a JSON file, I'll just put images over here so that you can understand that how does a CSV data look and how does a JSON data look. So over here the outputs are quite the same, but there is something to remember, that data.json file is actually a dictionary in Python. So what I can do over here is I can also print pd.dataframe sample as it's a dictionary, and I'll again get the same result. And like we did into the CSV file, if I'll write
Print sample dot toString, then what I'll get is the complete JSON file into a tabular format. So toString is used only when you want to print or you want to see the entire JSON file or a CSV file, and if you just want to view any 5 records, then you can just write data frame. Now, if we want to see the top 5 records or top 10 records, then there is a function called head which can print the first 10 records or 5 records or as many as you want. So I'll write sample. Firstly, I write print sample dot head and run it. And if you do not pass any parameter to head, then it by default prints the first 5 records, that is 0 1 2 3 4. And if I'll pass a parameter, let's say 10, then it prints 0 to 9 records, and so on. You can make it print as many records as you want. And in a similar way, if you want to retrieve data or records from the bottommost of this file, then you can write then you can use the tail function, which gives us data from the bottommost 5 records. And as again, if you do not pass any records, then it will give you the last 5 records. And if I'll again pass 10, then it gives us the last 10 records. So this is how these two functions are very helpful when you want to analyze a particular data. There is one more very important function in Pandas, that is the info function. Now what does this info function do is, we'll quickly take a look. I'll write sample.info, and now when I run it, I get info about this sample dataset. That, we'll just see line by line. What does it say? That this data set has 169 entries ranging from 0 to 168, and there are total number of 4 columns. And over here we have details about every column. That the first column is duration. It has 169 non-null elements. That means that no record is empty. In duration, pulse has 169, whereas calories does have 164 non-null, which means that there are 5 records that do not have any calories into it. So by typing info, you can get the complete information about a data frame or a data set. Now, this was the basics of the Pandas package, and it is very helpful for you to get started working with Pandas. Now, we will move to the intermediate part, which is data cleaning. So, let's get started. Firstly, we'll see why do we need to clean a particular data. So, for that, I already have a sample data over here. As we can see, there is an index, then duration, date, pulse, max pulse, and calories given to us. Now, in the date section, you can see that at some points there is no data over here. As you can see, NaN, and then over here you can see that this data has been taken as a integer instead of a string. Then even here in calories we can see that many records have an empty data into it. So while the computer is reading this, it can cause a very big problem, and you cannot analyze this data very swiftly, and it will keep on giving you errors again and again. So for that we need to clean this data. Now there are two ways we can clean this data. The first is that we'll firstly scan the complete data set, and then we'll remove the records where there is no data available for a particular column, or we can also fill some values to that particular column where the data is not present. So what I have done is I have made a CSV file named faulty data, which has some records with null value into it. So I'll firstly load that file. This is sample equals pd.read CSV faulty data.csv. Now after doing this, what I'm going to do is I'll write a command called as drop na. Now what does this do is, firstly I'll just type in, I'll store it in a particular variable, new data. I'll name it new data equals sample dot drop na. So what does this drop na does for us is that it scans the whole data set or the data frame, and then remove records from it that do not have particular data into it or have null values. Now what does drop na do is it creates a new data frame. So sample is our original data frame which has these faulty datas into it. Now this drop na function, it creates a completely new data frame which we are calling new data over here, in which there are no empty records present, but the original data frame does have it. So the original data frame remains untouched. So over here I'll just print, as I want to view the whole data set. So I'll do new data dot toString, and I'll run this. Hopefully we should get, okay, we have an error over here that says PD is not defined. Okay, I'm really sorry for this. I'll just import pandas as PD and we'll run. So as we can see, we have got our data, and now we'll just firstly take a look at faultydata.csv. So as we can see, faultydata.csv does have records where there are some empty cells available. But over here, this new data that is getting printed, we do not have any empty cells. As you can see, no null values present either in calories or in date. So this was how drop NA works, which is by removing, which is the first method, which is by removing a particular record. And if we want to fill a particular record, then the command that we can use is fill NA. Now how does that work is, instead of this drop NA, I'll write fill NA, and there is, what it does is that we need to give it a particular value. Now, if I directly want to make changes to our original file, which is faultydata.csv, then what I can do is over here where I am using the dropNA function, I can write a keyword in place equals true. And then after writing this, I do not need to store it anywhere. And I can just straight away write sample.toString over here. And if I run it again, then I will get the original data frame with removed records from it. So there is no need to make another data frame over here. But when you are cleaning data on a professional level, then it is highly advisable to create a new data frame and then work on it so that there is no data loss or data corruption happening any day. Now moving forward, this was the first way, which is removing particular records. Now if we want to add a particular value to a record, then the function that we can use, which is present in pandas, is fill NA. So what I'll do over here is, instead of drop NA, we are going to use fill NA to fill in records. So what I'll do over here is that I'll firstly remove this line, and again I'll add a new data variable, and this time we are going to use the function sample.fillNA, and I'll input a particular value that I want to fill at the null places. So let's say I'll add 390 at the null places, and after this data is added over here, I'll write new data dot toString, and I'll just give it a run. So as we can see, the places where there was null written, as there was a null written over here in date time, 390 has been inputted, and there were some values over here too that had some empty records where 390 has been inputted. I'm not able to find it, but yeah, now we are, this can be the one. So now there are no empty records, so it gets easier to clean the data and analyze the data. Now, like the drop NA function, we can also write uh, in place over here to make direct changes to our main data frame. Now, as I can see, there is one drawback with fill NA, that when I write 390, then what it does is it finds null places everywhere. It doesn't look at the columns. So for example, date also has 390, which is obviously something which we don't want. So what we can do is we can make changes only to a particular column also. So what I'll do is over here, I'll say that I want to make changes only to a particular column. Let's say, okay, I'll just firstly remove this, and I'll say sample, and it has a column named calories. Now I only want to add this particular data over there. So after choosing a particular column, I'll just write fill NA, and I'll say 5000, so it gets easy to locate where it has made these changes. And as we are making changes to the main data frame, so I'll write in place equals true. And now I'll over here write sample and give it a run. So as you can see, the changes have now not been made into the date section over here. It still has an NA, but rather they have been made only to the calories section. As you can see, there's a 5000 over here, there's a 5000 over here too. So this is the way you can make changes to a particular column. More ways by which we can clean data are by using the mean function or the median function or the mode function, which is already present in pandas. So we'll even take a look at that also. So it's quite easy to do that. What we'll do is that after we have read a CSV file, I'll firstly remove this from here. So over here I'll find the mean for calories column. So how I'll do that is, let's say X is the mean, then sample calories dot mean. This will give us the mean of the calories column. And now what I'm going to do is I'll just print sample dot fill. Now I'll pass X as an input and I'll set in place equals true because we are working on the original data frame right now. So as I run this, I get an error, and that error is on X. Okay, so the error is actually we need to write calories, and we see that the mean comes out to be none. This is because I have again made a small error which I keep on making. There's nothing new in this. Over here we do not need to print this particular statement, but we need to print the whole data frame to view the changes made. So now we should be getting a table. So over here we get a table, and now if you'll we'll just also print the value of X so that it gets easier to find X into this table. So X is 304.68, and as you can see on the 18th row we have calories turned up to 304.68. Also what I'll do is I'll also make sample print over here so that if we get data side by side then it gets easier. So as you can see, previously the 18th record had no value over here, but now the 18th record has 304.68 into it. So this is the way in which you can use mean function to input values. For writing, for using the median function, we'll just change this to median, and this time I'm not printing sample. Just comment this out, and now if I run, then again we are getting the same, not the same input because mean and median are different things, but yeah, the method is same, that calories has no empty spaces now. And similarly also mode can be used, but while writing mode I'll also write 0 over here, and now I'll run this. So 300 is the mode, which is the most frequently occurring number, and I wrote 0 over here because it might be that mode may come up with a list, and out of that list we want the first integer to be as our mode. So as we can see, 18th record has 300 now, and I believe 23rd record was also null, so it has 300 now. So these were the other three ways by which you can input data into a list. Moving forward, we had previously seen that there was also a mistake in the date column in the 26th row, that this is not a date format. This is an integer format over here. So what we'll do is we'll convert this into a date format. How do we do this? It's quite simple. I'll just remove all of this. And what I'm going to be doing is I'll firstly select the date column for us. And into that date column, I'll use a function that is to date time. What this function does is it converts everything into a date format. And what do I want to convert? I'll write sample and the column that we want to convert, date. So what this does is it will convert this integer into a string like this, into a date format, and then I'll just print sample dot toString just to see what is our result. And as we can see now, everything has been converted to a date, a proper date, and the problem that we had on the 26th record has also now got solved. So previously, as we can see, I'll just print again sample so that we can directly compare. So over here we see that this was a string and we had a problem on the 26th line, but now these things are being converted to a proper date format, and on the 26th record also we see a proper date format.
So moving forward now, we'll take a look at how to find wrong data and how to again. So moving forward, we'll take a look at how to clean wrong data that is present into our data frame. Now, wrong data doesn't only mean that there is a problem in the format or there is an empty row in our data set. It can be anything. It can be a typo or a miscalculations happening over here. So if you take a close look over here, in the duration column on the seventh row, we have duration as 450 minutes. Now that's obvious, that's logical that nobody can work out for 450 minutes. That accounts to almost 9 hours of working out. Not 9, but 7 to 8 hours of working out. So nobody can work out so much. So we know that there is a typo. Instead of 45, 450 is written over here. So what we are going to do is we'll just firstly locate this particular record. That is, I'll just write sample.lock, and inside I'll write the row number, which is 7. 7 is the index of that particular record, and then I'll write the column in which I want to make the change, and then the data that has to be changed, and I'll just run this. After running, what we'll do is we'll just print the data set to see what's going on. So now as we can see, the 7th record has been moved to 45. So what I'll do is, let's say this was a very small data set, so we found out that okay, there is a mistake over here. Let's say that you have a data set of 10,000 records in it. Then what you can do is you can create a dynamic searcher which will actually find a record and it will just change it. So what I'll do is, let's say that whenever the duration goes about 120 minutes, you need to change it and make it equal to 120. So what I'll do is, for x in, I'll say sample.index, because I want to iterate through the index of this particular data set. If sample duration goes greater than 120, then what I would like to do is sample.log that particular. Okay, so firstly what we need to do is, we cannot find it this way. I'll also need to use a lock over here. So I'll say if sample.log of any record is greater than 120, then what we'll do is, in duration. Otherwise, it will start finding it in every column. So if such a thing happens, then we'll just make it equal to 120. Okay, and right now there is nothing related to 120, so what I'm going to do is I'll just change it to 25. So I'm expecting everything, every record over here to change to 120. So I'll just print sample.toString and just give it a run. I'll run this and we get that every record has a duration of 120 minutes now, which is because we have iterated through these items and changed the time, manipulated the time as we wanted. Moving forward, we'll now try to remove duplicates from our data frame, which is obvious if a data frame has been set manually, or while some errors, there can be duplicate records present into a data set. So what we're going to do is we will try to remove, we'll first try to check if there are any duplicates available. So we know that the 11th and 12th record, as you can see, are the same. They are completely the same, no changes in any of the columns. So for finding whether there are duplicates or not, we'll just try to print sample dot duplicated. I'll just zoom in so it's quite visible. Now this duplicated function actually returns a boolean to us, which is either true or false. If there is duplicate, then it should return a true to us. So I'll run it and we get that the 12th element is true, and we just check every other element is false, but the 12th record is true. So once we found out that there is a true record, what we'll do is we'll just drop that particular, we'll not print it, but we'll just drop that particular duplicate. And for dropping, you cannot use drop NA over here because there are no empty records over here. So we'll use sample.drop duplicates, and then again I'll just print the whole data set. Now there is one more thing. I'll over here write in place equals true because I do not want a new data frame being formed. I just want to work on my original data frame. So I'll just run it and print it. So there is an attribute error over here. Data frame object has no attribute drop duplicates. Okay, so there is a typo that I have made. It is actually drop duplica, and I'll just give it a run. So we'll see that now there is no more duplicates. The 12th element has been removed. So this is a way in which you can firstly find whether duplicates exist, and then if there are, then you can just remove it. Again, if you don't want to, like, as this was 30 records over here, so I was easily able to spot the true over here. But if it's 10,000 records, you cannot spot it. So what you can do is you can just apply a for loop, or even you can just put an if condition that if true occurs, then directly use this particular statement. So I'm not writing the code for it. You can just use your logic and print it.
Moving forward, now we are going to take a look at the advanced section of Pandas, that is learning about data correlation. Now, what does this term actually mean? That how much is our data that we have, the records that we have are related to each other. That is what we are going to learn over here. So firstly, what I'm going to do is I am going to again call this file of mine because this is a manipulated file. I want to see how much is my data related to each other in the original data frame that we got. So I'll over here write in I'll store it in a variable, let's say given data equals pd dot read, as this is a CSV file. So I'll say read CSV data.csv was the name of our file, and now what I'm going to be doing is I'll write given data dot cor, which is the function that we used when we want to find the correlation between all of these columns, and I'll just give it a run. So over here I get a table which our table actually had a lot of records, but over here we have duration, pulse, max pulse, and the same thing over here. So we'll just understand it in a second. Now it shows that how much is duration related to duration. So it's obvious that duration is completely related to duration. So the value is 1. The values normally in this table range from minus 0.9 or minus 1 to 1. So that means that how do we find that the particular relation is good? So if a value is above zero point 0.7 or even in negative zero point 0.7, then we consider it as a good relation. Over here you can see we have a value that is 0.09, which is very low. So I will conclude that duration and max pulse are not at all related to each other. So if I'll see that duration and calories, then it is a very good number, which is 0.92, and which is very obvious that if you increase the duration of your workout, then you will burn more calories. So duration and calories are directly related to each other. But at the same time, over here we'll see that duration and pulse are at a negative number. What does that mean? That if you increase the duration of your workout, your pulse is going to decrease. But if we had a minus 0.9 over here, then I would have said that if one column increases, then the other is decreasing. But as the number is not very good, minus 0.15, so I'll say that the pulse wouldn't get affected a lot. At the same time, if I'll come to pulse, then pulse is 100% related to pulse. So we have a one number over here. And if pulse increases, then as pulse and a max pulse have a good number, I'll not say very good, but still a good number, that is 0.78. So if pulse increases, then max pulse will also increase. If there is a positive number, that means that if one data increases, then in action the other data will also increase. That means that is a positive number, and negative means that if one data increases, then in action the other data will decrease. Coming on to calories, we see that again calories and duration are directly related. That if calories are more, that means duration is also again going to be more. So this was how you find a relation between columns with each other, and it is very useful to check the correlation of these columns when you actually start working on the data set. So it gets easier to understand the concept of this particular data set. Now we'll take a look at the last concept of Pandas package, that is plotting a graph. If we want to plot this particular data set in a graphical form, then how to do it. Now, when you are working on a very large data set, if you plot a graph of it, then it gets very easier to predict some patterns that may be forming. So it's always advisable to also print a graph of a particular table or a data set to find more new algorithms or patterns getting formed. So over here we are going to use a package that is matplotlib, and I've already made a detailed video of how to get started with matplotlib, which you can see over here in the I button. So I'm not gonna explain the functions of matplotlib, so I'll just directly import it, matplotlib, and over here we are going to plot a graph for our data set, that is given data. So I'll say given data dot plot a graph, and then I'll just print it so that the graph gets displayed. So over here we can see a graph that this blue line represents the duration, yellow is pulse, green is max pulse, and the red is calories. So upon this I can know that when the calories is the highest at this particular number, that is 100, and I can also just add labels over here. It can be, I'm just putting random y equals, that's a duration, and I'll run it. So we get a graph that is for duration and calories, which is quite a very different graph because there are many values that are present over here. So we can also plot a histogram if you want. And for plotting a histogram, let's say I only want to plot a histogram for the duration column. Then what I can do is I can just take that particular column and plot graph of it. And in plot, this time I'm going to write the kind of the graph that I want, which is hist, which means histogram. And we'll run this. So I get a frequency graph that when my time increases to 50, then calories are going above 100, and so on. We get a graph. You can also change colors of these graph, and everything I have taught in we have seen in the matplotlib video. So over here we are completed with the basics of Pandas package. I'll also provide the link for the official documentation page of Pandas. You can do a lot more with Pandas, so you can just read the documentation and also use different kinds of functions that are present in Pandas. Hope you liked this video of mine, and please do comment that the series that I've started off explaining packages, different packages of Python is worth it or not. So thank you.